All right, 8.3, we're into trigonometry, trigonometric integrals. 8.4 is also going to have to do with trigonometry, so hope your trig is strong. If not, you better get to work, because here we go. All right, so we're going to start dealing with things with sines. It's the beginning. This is the beginning of this section. We're going to deal with just sines and cosines. They're going to be raised to odd powers and even powers. Odd powers, not a big deal. Even powers, still not a big deal, but it's a little bit more work. So odd powers, and they're all going to be combined. Sines and cosines put together. It's no biggie. We got this. So sine cubed of x dx. Now we just have to know our one fundamental formula from trigonometry. So sine squared plus cosine squared is equal to 1. Now, can I have a real conversation with you? If you didn't know that, what the hell are you doing in Calc 2? I mean, that's just an honest question. How did you get here if you didn't know that? All right, I assume you know that. So we're going to have to come back for that in a second. But what it allows us to do is if we ever have even powers of sine or cosine, like an even power, well, dude, we can solve. Like, look at this. We could say cosine squared is equal to 1 minus sine squared. Or we could say that sine squared is equal to 1 minus cosine squared. So we can always go back and forth between the two of them. And what we're trying to do here is create a U sub. That's the whole game. We're trying to create some sort of U sub out of this. So I'd like to write this a little different and call this sine squared of x times sine of x dx. Okay, so we broke it down. We took something over here, which is going to end up becoming, this is going to become our du in a second. We're using it so we have something that we're going to be able to sub with. But for now, let's take our sine squared and let's call it 1 minus cosine squared. So let's do that substitution. We'll call this 1 minus cosine squared of x instead of writing in sine squared of x. And there we are. We're ready to go. Our U sub is just staring at us. It's begging us. It's saying, come on, take me out. Take this cosine out, not the square. Take the cosine out. We're going to say u is equal to cosine of x. Therefore, du is equal to negative sine of x dx. Well, there's a sine of x in there, but let's take that negative. Let's bring it over to the other side. You got a pencil or a erasable writing utensil, don't you? You wouldn't take math without it. So now that means we can go through and just change that out. There's our sine of x dx. Let's go. So there's our negative. And then we have 1 minus something squared. And that something squared is u. And then the sine of x dx? Well, shoot. That's just du now, isn't it? Excuse me. That's solvable. That's solvable. I'm actually going to bring this in and call this u squared minus 1 du. Can you see it by bringing the negative in? It just turns it around. So now let's take an antiderivative on it. We got 1/3 u cubed minus u plus c. And what was our u to begin with? Oh, it was cosine. So here's our answer. 1/3 cosine cubed of x minus cosine of x plus c. There you go. That's how we're going to deal with odd powers of sine or cosine. We break one of them off, and then we use the Pythagorean theorem for trig to sub. That's the game. All right. Let's move into this long cosine to the 4th. No. So now we move into our next one, even powers of sines and cosines. That means the reduction formula, or otherwise known as the power reduction formula, comes into play. So here we go. Let's write it off to the side. If you ever have sine squared of x, this is 1/2 times 1 minus cosine of 2x. If you have cosine squared, that's 1/2 times 1 plus cosine of 2x. The formula may look a little different to the way if you look it up. I write it this way just because it's the ease of use. So that is our power reduction formula when it's dealing with sines or cosine squared. Trig does not, or integrals do not play nicely. Do not play nicely when it comes to integrals. All right. Integrals don't play nicely. What did I say? I just lost my train of thought. Yeah. Even power, sines and cosine. Integrals, bad. Gotta use this. So let's go. Let's replace out our cosine squared with this 1/2 1 plus cosine of 2x all squared. Oops. I need to put this thing actually around this. There we go. Now we square it up. Ooh. Now we can square it up and take that 1/4 to the outside, right? That 1/2 all squared. And now we're going to square our 1 plus cosine of 2x, and that's going to become 1 plus 2 cosines of 2x plus cosine squared of 2. Oh, shoot. We created another square. How are we going to deal with this one now? Now it's got a 2x inside of there. Well, what happened here is we doubled up inside, whatever that was. So this is just going to become 1/2. 1 plus cosine of what's 2 times 2? 4. Now we can replace that one out. But I'm actually going to bring this in and write it this way. Sorry, I've done these many times, so there's reasons why. You will probably have to mess around with it quite a bit. All right, as we learn. And now we can replace. Woo! We got it. All right, so let's put our numbers together, and then we're going to be able to integrate. And I'm going to cheat with these because, yeah, they're U subs, but that's the 1 and the 1/2. But really, are they U subs? Are they honestly U subs? So I'm going to jump a step here. I'm going to jump a step, just off to the side. If we're going to take the derivative on cosine of 2x, isn't that just -2 sine of 2x? What did we do with the constant? Didn't we multiply? So when we take an antiderivative, what do you think we're going to do? We're going to divide by the gosh darn number. Why the heck are we going to add extra work to this? So this is 1/4 times the quantity of 3/2 x. Now, the antiderivative of cosine is sine. Now, we're not going to multiply by 2, but divide by 2. The antiderivative of cosine is sine. We're not going to multiply by 4, but we're going to divide by 4. You can do your U subs off to the side if that makes you happier, makes everything better. So at this point in time, I think I'll just leave it factored. Why not? It doesn't hurt anything. We could clean it up in a different way, I guess, but I think this is sufficient. And there's our solution. So you wanted to be a STEM major, huh? There we be. There's a cosine to the 4th. You'll probably see a sine to the 4th at some point in time. So we're going to get in. We're going to play with these. We'll start mixing them up a little bit. We typically do want to stay away from those even powers of sines and cosines because, as you can see, that power reduction formula gets to be a little complex. Fortunately, I know a lot of my students have taken trigonometry with me, so you've already played around with this ad nauseum. If not, you get to be in the same boat that I was going into Calc 2. I didn't know there was such thing as a power reduction formula. I had to learn all this stuff while I was learning that calc. So you can too if you got the time. So, all right. We'll mix it up. We'll do a few more problems in the next, and then possibly we'll move to some tangents and to some secants after that. All right. Take it easy.